In this video, we're going to complete problems that require multiple steps using multiple properties of logarithms in order to solve. So this first problem here, we have a log base 2 of x plus a log base 2 of x plus 2, all equal to 3. Well, I see an addition here of two logs with the same base, so that means that I can combine these into one logarithm where I take the main terms inside and multiply them together. So I'm going to have log base 2 of x times x plus 2, all equal to 3. And since this is a multiplication here, I can go ahead and distribute the x to both of these terms if I want to expand this out. So I'm going to get log base 2 of x squared plus 2x, all equal to 3. Finally, I want to take this logarithm and turn it into an exponential because that's the next step in order to solve this. So I'm going to take my base of 2 and I'm going to move it over as the base of the exponential term over on the other side to get rid of my logarithm. So when I do that, I'm going to go ahead and end up with x squared plus 2x, main term inside of here, equal to 2 to the third power, which we know is going to be equal to 8. Then I'm going to get all of my terms on the left side, since I'm using a quadratic here and I want to figure out how to solve this, get all my terms to the left side and set the right side equal to 0. And then I'll be able to do some factoring. At this point, if I want to factor it, it's going to factor into x plus 4 and x minus 2. All of that equal to 0. And so I can look at what's going to make the left term equal to 0, what's going to make the right term equal to 0. And that's going to be x equal to negative 4 or x equal to positive 2. The last thing I need to do is make sure that these are not going to cause me to take a negative logarithm. So I need to plug these x equal to 2 or x equal to negative 4 in my original equations. If I do that, I have log base 2 of 2, which is fine. Log base 2 of 2 plus 2, or 4, that's positive, so that's okay. Try the negative 4, log base 2 of negative 4, that's not going to work. Got a negative in there. So I'm going to cross that out, and we're left with only x equal to 2. Next problem here, we have log base 4 of 3x plus 2 equal to log base 4 of 5 plus log base 4 of 3. Well, on the left side, there's really nothing I can do at the moment, but on the right side, I have two logs that are being added together, and so that means that I can take their main terms and multiply them together in one log. Again, we have the same base, log base 4 on both. So what that's going to leave us with is we had our 5 and our 3 that were in separate logs being added. Now they're being multiplied in the same log. So that's going to take us to log base 4 of 15. At this step, we see that we have log base 4 of something on one side and log base 4 of something on the other side, and that's all there is in this equation, so we can just take the inner parts and set them equal to each other. So 3x plus 2 is equal to 15. And now it's pretty straightforward algebra. Subtract 2 from both sides, divide by 3, and we're left with x equals 13/3. Next problem here, we have log base 2 of x plus log base 2 of x minus 6 equal to 4. Once again, we have addition of logs with the same base, so I'm going to combine that into one term, log base 2 on the left side, of x times x minus 6. We've got our x, I got our x minus 6. Since the logs are being added, I'm going to multiply the terms in one equation here. Now I'm going to expand out my x and my x minus 6 so that I'm left with log base 2 of x squared minus 6x. All of this still equal to 4, as it always was. Now if I want to solve this, I'm going to undo my log by taking my base of 2 and moving it to the other side as the base of an exponential. So I'm going to have x squared minus 6x all equal to 2 to the 4th power. I'm going to take my base 2 and make it the base of my exponential here. Well, 2 to the 4th evaluates to 16, and I'm going to subtract that from both sides so that I can go ahead and solve the quadratic. The way that you solve quadratics Again, easiest way is to start with factoring. If that doesn't work, there are other techniques. But this is going to factor down nicely into x minus 8 and x plus 2. All this again equal to 0 because we're factoring. So that leaves us with the solutions x equals 8 and x equals negative 2. Need to make sure that both of these are going to work. We take negative 2 and we plug it into our original equation, not any of the interim steps. So we go back to our original equation, and log base 2 of negative 2 is going to be a negative log. That's not going to work. Can't do that. Try our 8. Log base 2 of 8, that's fine. Log base 2 of 8 minus 6, which is 2. So 2 is a positive number, so that's okay. Still fits in our domain. So that's going to leave us only with x equal to 8. Last problem here. We have terms on both sides. You might see that there is a subtraction of logs with the same base and might want to jump straight into that. However, you can't do that because there is a coefficient out front. There has to be no coefficients when you do that combining step. So let's go ahead and get rid of that coefficient. We have a 4 out front, and what we're going to do is we're going to move that to the exponent of this x term. Because whenever we have a coefficient out front, we can make that the exponent of the main term in the log. So nothing else changed in this equation, but we took that 4 and moved it up to the exponent here, so we have log base 2 of x to the 4th power. Now there's no coefficients out front, so now we can go ahead and undo the subtraction of logarithms by combining this into one term, log base 2. And because it's subtraction, we're going to have the first term, x to the 4th, over the second term, 5. So we have log base 2 of x to the 4th all over 5, and then our right side, of course, never changes. At this point, we have a log base 2 of something and a log base 2 of something else on the other side, and no other terms going on, no other coefficients. So we can set the inner parts equal to each other. So x to the 4th over 5 is equal to 125. Once you have it here, you multiply both sides by 5, and you're left with x to the 4th equals 625. And on this last step, you might be tempted to want to take a square root of both sides, do it one step at a time, and that's totally fine. You're going to end up with the roots of 5, negative 5, 5i, and negative 5i. However, we don't care about imaginary roots when we're doing logs, so we can go ahead and just punch this in our calculator and get the 4th root, and we're going to get positive or negative 5. Now, once we get that plus or minus 5, we try to plug it back into our original equation. Negative 5 here, we're going to have a log base 2 of x, and if x is negative 5, that's not going to work, so we're going to go ahead and get rid of that solution. And then our positive 5, log base 2 of 5, okay, that's fine, log base 2, and the rest of these are constants, so our 5 will work for us, so only x equals 5.